So you have this solution generally. This solution, let me consider NaCl solution. It consists of water and sodium chloride. Sodium chloride is the solute. This is a minor portion, is it not? Smaller portion. So it can be represented by a number 2. Whereas solvent, it occupies major portion, so you can call it 1. So when I say W1, it is the weight of solvent. Please note down weight of solvent. Okay. You cannot take, see, for example, you can take 5 grams of sodium chloride and dissolve it and make up to, say, about 1 liter, 500 ml, 200 ml, something like that. Okay, in terms of volume. But you cannot take 1 kilo of solute and dissolve it in 10 ml of water. That is ruled out because you cannot dissolve it. So in that case, the solute portion should be a smaller one, say a teaspoon, something like that. Okay. So the
Yes.
solvent portion should be the major quantity. So that is why we give priority to W1 here. And when I say W2, that is the weight of solute. So usually if it is weight means we give it in gram. Okay. And let me consider how we can simply express the concentration of such type of solutions like sodium chloride. So initially that is we can have this percentage concentration and this can be W by W, weight by weight percent or weight by volume percent or volume by volume percent. Do you understand this? Where
Yes, sir.
you need not know about the molecular formula, molecular weight, etc. You just take the weight and divide by the, for example, weight by weight percentage means take the weight of the solute divided by in a fixed quantity of weight of solvent. And that is as solution into 100. Are you able to follow? For example, when
Yes.
I say W, it consists of W1 and W2. What is W1? Weight of solvent. W2, weight of solute. W, weight of solution. Do you understand?
Yes.
So when I write W by W percentage, this is nothing but W2 divided by W1 plus W2 into 100. Okay. And since we know W1 plus W2 is equal to W, I have simplified. So we can put W2 by W into 100. So as a mathematical expression, we can do it. Similarly, the W by V, that is the volume percentage. So in this case, let us have weight of the solute divided by volume of the solution into 100. Do you understand this? For example, in
Yes,
order
sir.
to prepare 5% NaCl solution of 200 ml, what you are supposed to do? So this is given as weight by volume percentage because this is volume. So you can put this is 5%. And weight by volume percent is formula W2 by V into 100. Got it? Okay.
Yes, sir.
So W by V is 5%. And what is the weight? W2 we have to find out. What is the volume? Volume is given as a 200 ml. This is given in ml and this is given in gram. So into 100. So you can work out this as 2. This is also 2 5s are 10. So W2 should be 10 gram. Is it not? So what does it indicate? That is, when you take 10 gram of NaCl and dissolve it and make it up to 200 ml solution, that results 5% NaCl solution. Do you understand this point?
Yes, sir.
So similarly, can you calculate, take down, what is the weight required for NaOH solution of concentration 0.05%? So what is the weight I'm supposed to take in say about 500 ml of NaOH solution? So what you can do, tell me, let me write. The formula is W. The formula is this
Yes,
one.
sir.
So you can follow the same. W by V percentage is how much? 0.05. That is equal to
0.05 is
W2
equal to W2 upon 500 into 100.
into 500. 100. Okay. So you can,
Then 100.
okay. So W2 is equal to how much? 0.05 into 5. That is 0.25 grams.
25.
So we have to take this. So I think this kind of mathematical operations will be very easy for you to calculate the unknown, I mean the unknown quantity or the quantity of the solute to prepare a particular
Yes.
concentration. Okay. Now I'll make it a point like this. I have 0.1 gram that is oxalic acid. Okay. And I am dissolving this in 250 ml, dissolving and make up to 250 ml solution. Now, what is the weight by volume percentage?
So the weight by volume percent will be equal to 0.1 divided by 250.
So, the formula is a 0. W by volume percentage is equal to, what is that? W2 by volume into 100. So, you have to replace this. So, W2 is zero point 0.1 and V is 250 ml into 100. Okay. Now, tell me the W by V percent.
So it will be
10 by 250, is it not? 100 into 0.1, 10 divided by 250, right? And you can answer 0.
0.04%.
So 0.04. So do you understand this? Okay.
Yes, sir.
Right. So likewise, you could be able to calculate immediately based on the formula that I have given to you. Okay. Right. Now let us proceed with the other set. For example, even in the percentage, we have got W by W percentage, W by volume percentage, and the volume by volume percentage. In case of any liquid that is dissolved in another liquid, like milk dissolved in water. Okay. So in that case, you can make use of this volume by volume percentage. That is equal to, you can call it V2, the volume of the solute. See, irrespective of whether the solute is a solid or liquid or gas, but you have to consider definitely as a solute, you can put 2, that's all. So V2 means the volume of the solute divided by volume of the solution into 100. What do you understand from volume of the solution, which consists of two parts, solute and the solvent? So in that case, V is equal to what? V1 plus V2. Do you understand this?
Yes, sir.
Right. So this part is regarding the percentage. Now let us move to the molarity. M stands for molarity. Take down molarity. Similarly, we have another concentration term that is called molality. This is expressed in smaller case, lower case. This is lower case, this is uppercase. Uppercase represents what? Uppercase M, molarity, R-I-T-Y. This is L-I-T-Y, litty. Okay. So that is the difference between these two. For instance, when I say molarity, M is equal to number of moles divided by volume of the solution. This is given in liter normally. Okay. And this is given as mole, number of moles. Okay. Similarly,
Yeah.
you have here that is M is equal to the same number of moles of solute divided by, here you can put W. So here it is nothing but kg, weight of solution in kg. Do you understand this?
Yes.
Suppose if it is given in terms of gram means then you have to divide by 1000 and make it as what? N2 into 1000
Kg.
divided by W. Okay, right?
Yes, sir.
Okay. Now this N2 is nothing but W2. That is, N2 is moles of solute that I already expressed. 2 represents solute. So in that case, N2 is equal to W2 by M2. Do you understand this? What is N2? weight of solute divided by molecular weight of solute. So I can replace this N2 by W2 by M2. Got it? Okay.
Yes, sir.
So N2 1 by P. Done. Therefore, M can be represented as W2 by M2 into 1 by V.
Where
Here,
did
this
B
is
come from?
W, not
The
this is W, so W. But in this case, you can call it W2 by M2. Here it is expressed in volume, so you can put V. Okay, so this is molarity, right? So this is molarity, this is
stands for
molality. Pardon?
M stands for.
Capital M stands for molarity, this one.
Also,
Mm.
that I know, like W2 on M.
M2, that M2 represents molar mass, molecular weight.
Okay, sir.
Okay. So molar mass means that is, for example, if it is the water, then you can call it the molar mass of water. Okay. This is molar mass. In case of a solute, means let us consider sodium hydroxide, that is a solute. So let me say M2, MnAOH, which is nothing but 23 plus 16 plus 1, that is 40 gram. So you have to
Yes.
express 40 gram per mole. That represents the molar mass. Okay.
Yes.
Right. Now let me work out some problems based on this molarity followed by molality. First, let us take up molarity. Right. So I have 4 gram of NaOH that is dissolved and made up to 250 ml solution. Okay. Now, what is the molarity it gives? So this is our problem. So what is the equation for molarity? Molarity is given by N2 divided by V, right? Another formula, molarity is equal to W2 by M2 into 1 by V. So you know very well this W represents gram, weight of solute in gram. What about this? This is the molar mass in gram per mole, right? And what about this one? V is in liter, volume of solution, okay, in liter. So now let us substitute. So M is equal to what? W2 it is given 4 gram, okay. You can put gram here. Then 250 ml, molar mass. For NaOH, you know already, sodium 23, oxygen 16, hydrogen 1, so 40 gram per mole. So you can put 40 and put gram per mole. Always have the practice of doing the units also simultaneously, right? Then what about this V? That is nothing but the volume of the solution. This is given in ml, but what I suggested, it should be in liter. So what you're supposed to do, you have to divide by 1000, is it not? In order to convert this into liter. So
Yes.
250 divided by 1000. So therefore 4 divided by 40 into 1000 divided by 250. It means 4 times, and this is 10 times. So zero point 0.4. So the molarity is a zero point 0.4. And what is the unit here? Gram, gram per mole, and 1 by liter. Is it not? So gram, gram cancel. So it gives you mole per liter. Do you understand this? So you have to declare this as mole per liter. Okay, got it? Okay, Prisha, done? You got it? Any doubt?
So,
So let me proceed with the another one, that is molarity. So we'll try to calculate the same in terms of molality also. Okay. I'm taking the 4 gram in your OH, the same in your OH. Then instead of 250 ml, let me take 250 gram of solution, NaOH solution. Now, what is the molality? Okay, let us calculate this. Right. So what is the formula for molality? M is equal to, what is that? Tell me. W2 by and mu.
Two by M2
M2
into W into 1 by W.
1 by W. And what about this W? It is in kg.
Kg.
This represents weight of the solution, not weight of the solvent only. Weight of the solution.
Solution.
But in case of dilute solutions, you can take this as weight of solvent itself. Okay. Because as far as weight,
Yes.
since it is a very dilute solution, weight of the solvent is a dominant one. So you can take straight away W as W1. Otherwise, it is nothing but W is equal to W1 plus W2 only. What is W1? Weight of solvent, right? And what is solution? Solute? This one. So weight of solute, right? Okay, right.
Yes, sir.
Now, you can substitute. Now tell me, let me write. M is equal.
No, sir. 4,
M is equal to
4,
4 foot gram.
uh, 4 gram into divided by 40 gram.
540
So because we have to take the molecular weight.
molar mass of solute into
uh,
1 by
1 by 250 gram, but we have to convert it into kg, so we did 1000 by 250.
so 250, you can put 1000 here. Okay, done.
Yes.
Now, so gram divided by, what is this? Gram per mole. Okay, right? Gram divided by gram per mole, and then 1 by, what about this one? This is in kg because we are already converted, is it not?
Yes, sir.
So kg. Okay. Now tell me.
So 0.4.
0 0 cancel, 4 cancel, and this is zero point 0.4.
Yes.
Zero point 0.4
zero point 0.4 mole
mole.
kg, mole per kg.
Very good. So don't forget this. Per kg. So in the previous case, we got it mole per liter, but in this case, we have got mole per kg. You understand this? Okay, so you have to be very careful about the units also. Okay, so now let me proceed with the another set of concentration expressions. So let me summarize. This is the percentage one where we have got three types of percentage. One is weight by weight percentage, another is weight by volume percentage. Then third one is what? Volume by volume percentage. Then we discuss about the molarity where we know the expression for a mole. Mole is nothing but weight divided by molar mass. Okay. Then we were explaining about the molality also. Okay. Now let us further proceed. We have got, so you can put 1, 2, 3, and 4. So here we will be discussing about the mole fraction. This should be pronounced as chi. That is CHI. Chi. Okay. So chi 2 means mole fraction of the solute. So let me explain about this. This chi 2 is nothing but N2 divided by N1 plus N2. That's all. Okay. And this N1 plus N2 can be called N also. So you can simply put N2 by N. So this is the mole fraction. And this is also another expression for concentration. Okay. Then we have parts per million also. Okay. So this kind of a concentration expression is used in the case of, excuse me, hardness of water. Okay. So in the case of very dilute solution, we can make use of it. So this is nothing but weight by weight of the solute dissolved in the solution into parts per million, so 10 power 6 you can put. So 1 million is nothing but 10 power minus 6. So I have taken this 10 power minus 6 as 10 power plus 6. Okay.
Yes.
In the numerator. Okay. So it means this much parts per million. Okay. Then we are going to discuss a very important unit called that is normality. Let us discuss about this one also. It is represented by n. So n is given by EQ2 divided by V, where V is volume of solution in liter. EQ means equivalent. Okay.
Yes, sir.
Now let us have this discussion. So normality is nothing but equivalent of the solute divided by volume of the solution. Equivalent of the solute is nothing but that is just like in the case of n is equal to weight by molecular weight. So similarly, you can have this is weight divided by instead of molecular weight, you can put gram equivalent weight of the solute. And what is gram equivalent weight of the solute? Which is nothing but that is molar mass of the solute divided by valency factor. Okay, so E is called valency factor. For example, for sulfuric acid, the valency factor is 1. For HCl, the valency factor, so sulfuric acid 2. For HCl, 1. For NaOH or KOH, it is 1. For KMnO4, it is 5. So you may ask me, that is, how do you remember all these things? This is based on number of electrons transferred during the reaction. Okay. For example, when I say valency factor, let me tell something more about this valency factor E. So in the case of acid, this represents the H plus concentration, that is H plus presence. How many H plus it has got? In the case of a HCl, it is 1 because it has got 1 H plus. In the case of H2SO4, you have got 2 because it has got 2. In the case of H3PO4, phosphoric acid, you have got 3. Okay. So based on the replaceable hydrogen, you can call the valency factor. Do you understand this? And similarly
Yes.
for base based on OH minus. For example, for NaOH, you've got one replaceable OH, so 1. For calcium hydroxide, you've got two replaceable hydroxyl ions, so you can put 2 like reciprocal. And in case of salt, you can have the dominant valency. Dominant valency. For example, if it is a BaCl2, you know very well that is for barium, the oxidation state is 2. So that is why on crisscross it becomes a 2 and for chlorine 1. So you can call it 2. That is the dominant valency. But immediately you will tell me, sir, what about this redox, that is oxidant or reductant, oxidizing agent or reducing agent? In the case of KMnO4, when I put, you know very well about this, this is plus 1. Okay, this is plus 7, this is minus 2. Definitely you will ask me, sir, shall I put 7? No. Why? Because in case of oxidizing and reducing agent, we don't take straight away the dominant valency. Instead, you know very well, oxidizing agent undergoes reduction, right? Reducing agent undergoes oxidation. So you must check it how many electrons are transferred in both. Okay, for example, you know very well in the case of a KMnO4, you have got Mn plus 7, that becomes Mn plus 2, means 5 electrons are involved. Okay, so in that case, for manganese, that is for KMnO4, what you are supposed to do? You have to divide by 5 because the valency factor is 5, right? Got it?
Got it.
In the case of H2C2O4, oxalic acid, H2C2O4. We know this is, what about oxalic acid? What is the oxidation state of oxalic acid? Carbon in oxalic acid.
Carbon sulfate.
H2C2O4. What is the
Three.
3?
Three.
So plus 3 becomes how much? it becomes carbon dioxide. Is it not? You know that reaction, CO2, where it has got plus 4. So plus 3 becomes a plus 4, correct? So it involves one electron, but you have got two carbon atoms, is it not? So it should be 2. So the number of electrons involved is 2 electrons in this case. So as far as oxalic acid is concerned, for oxalic acid, you have to consider the valency as 2, valency factor as 2. Do you understand now? Okay. I hope now you are very thorough with this oxalic. So let us try to find out the normality of oxalic acid. What is oxalic acid? Hmm.
So in the carbon case, how is it plus two? Don't we like isn't it only one?
But there are two
Okay. Okay.
there. In the case of oxalic acid, so when you look at this oxalic acid, what is the formula of oxalic acid? You know something about the organic acids, right?
Yes, sir.
These organic acids are generally weak compared to the mineral acids. You've got the mineral acid like a hydrochloric acid, nitric acid, phosphoric acid, sulfuric acid. Okay, they are all strong acids. What do you mean by acid? For example, we talk about the strong acid, weak acid. What do you understand from this? You please make a note of it. This will be very helpful to you. For example, let me call it electrolyte. Electrolyte. What do you mean by electrolyte? Electrolyte is an ionic conductor. That is, like metal, the conductor can be classified into two: metallic conductor and ionic conductor. Metallic conductor, metals where electrons are responsible for conductance of electricity. But in the case of ionic conductor, as solution, ions are responsible. So electrolyte is nothing but an acid. It can be an acid or base or salt that can conduct electricity in solution form or in molten form. So that is the correct definition for electrolyte. You understand this? So what is electrolyte? It can be an acid or base or salt that can conduct electricity, that is current electricity, in present, I mean, as solution form or in molten form. Do you understand?
Yes, sir.
Right. So this acid, base, salt that is in the solution or in the molten form that acts as electrolyte. Okay. So this can further be classified into strong electrolyte and weak electrolyte. Then strong electrolyte means what? They readily ionize the state of. Whereas weak electrolyte, they do not readily, very slowly only. And strong electrolytes, they undergo complete ionization. If you've got 5 moles of strong acid, all the 5 moles are dissociated. So completely ionized. Whereas this is incomplete ionization. Here, the degree of dissociation is 1 because all the moles are dissociated, whereas here only part quantity is dissociated. So, degree of dissociation is less than 1. Okay. You can cite an example like NaOH, HCl, H2SO4, etc. In this case, almost organic acids, ammonia or ammonium hydroxide, etc. Okay.
Okay, sir.
So, let me consider this oxalic acid. Its formula is COOH, COOH. But this is available as dihydrate. So you can say oxalic acid dihydrate. Now, what is the molecular weight of this? Can you calculate?
Yes, sir.
Great. See, for C, there are two carbon atoms, so 2 into 12. How much? 20. Very good. So for oxygen, it is 16 into 4. How much? 64. Then you have got two hydrogen, so 2. So it means how much? 2, 4, 6, 10 balance 1. And then this one, 7 to 9. And what about this? 90, 36, is it not? So 126. So 126 is the molar mass, right? So in this case, we are going to calculate the weight of 6.3 gram of oxalic acid, for which it is going to be dissolved in 500 ml solution, so that this gives the normality. Okay, so what is the normality calculation formula? N is equal to,
Normality, anything
let
equivalent
me do
of
one thing. You have this gram equivalent weight, right? You can replace this. So what it becomes, this is equal to W2 by M2 by E, right?
yes.
And this can further be substituted here. Therefore, N is equal to, instead of EQ2, you can substitute. So W2 by M2 by E into 1 by V. It means that is equal to W2 by M2 into 1 by V
By
into E. So this is normality. Okay.
yes, sir.
Now you can substitute. So N is equal to how much? W2 is 6.3 gram. Molar mass 126. So gram per mole. And then equivalence. What is the equivalence here? 2, right? Divided by, what is the volume of the solution? 500 ml. That is zero point 0.5 liter. Is it not? So 500 into 1000 here. So can you work out? That is in liter. And this is in equivalent.
So 0.2
0.2 unit.
0.2 mole
It is
per
not
liter.
mole. Mole divided by the valency factor means it becomes equivalent. So you have to say equivalent per liter. Okay. So for normality, you have to call it equivalent per liter. For molarity, you have to call mole per liter. Correct?
Okay, sir.
Now you have one important equation here. See, that is, I introduced it here. That is, N is equal to, what is that? N is equal to W2 by M2 into 1 by V into E. You just look at this part alone, which is nothing but molarity. Is it not? Therefore,
Yes.
you can call it this normality is equal to molarity into valency factor. Okay, this is another equation you can develop. So once you know the molarity, you just multiply by the valency factor so that you are able to get the normality. So never forget this. Okay.
Yes.
So now can you summarize what are the different types of what do you call the concentration expression we have discussed so far? Please summarize.
So the first one is the percentage concentration. So that is one to three parts. The first one is a W by W percentage, which is the weight of the solute upon the weight of the solution into 100. And the second one is W by V percentage, which is the weight of the solute upon the volume of the solution into 100. Then the third one is the volume by volume percentage, which is the volume of the solute upon the volume of the solution into 100.
Second.
Then the second the second thing is the molarity. which is the number of moles on the volume in liter, which can also be written as W2 upon M2 into 1 by V. Then, then the third one is molality, which is expressed by small m, which is small m is equal to W2 upon M2 into 1 by W. Then the fourth one is the chi, which is the molar fraction, which is equal to N2 upon N1 plus N2, which can also be written as N.
Parts per million.
And then the partial
Parts per million.
parts per million, which is W2 upon W into 10 to the power 6. Then we have the sixth one, which is normality. And normality is equal to W2 upon M2 into 1 by E into the E, which is the valency factor. And we can see that W2 upon M2 into 1 by V is also molarity. So N is also equal to molarity into the valency factor.
So what you're supposed to do is I will give you plenty of worksheets based on each concentration terms. Try to work out all those worksheets, okay? So that you can expertise in the concentration terms, right?
Yes, sir.
And meanwhile, I'll be sharing our e-learning web pages and along with the playlists of videos also. Please go through that. So try to cover up all those things, right?
Okay,
So
sir.
there will be some quiz and you can, I'll send you the link. So meanwhile, you please go through the exercise problems given in your textbook and please proceed that, right?
Okay, sir.
Okay, see you, bye.
Thank you, sir.